we are to begin the new lesson of your science, chapter number 5, and it is metals and non-metals. So before we start this lesson, let's revise some of the things which we have done in chapter number 1 and chapter number 2, because chapter number 1, things you have done in chapter number 1 and chapter number 2 has very good link with this lesson. So first of all, in chapter number 1 we have defined metal, and we have defined metal as any those elements which can gain electrons and become positively charged ions. Let's take an example. Say sodium. Atomic number of sodium is 11. Its electronic configuration is 2, 8, 1. We have studied one rule in chapter number 2, that is called octet rule, and according to that rule, it says that for every element they will try to have 8 electrons in their valence shell to attain the stable electronic configuration of their nearest inert gas. So first, for sodium, the valence shell of sodium is this one. So sodium will try to have 8 electrons in their valence shell. For that, sodium need to lose this 1 electron, or sodium need to take 7 electrons from outside. It need to lose 1 electron. So losing 1 electron is more easier and it will require less energy than gaining 7 electrons from outside. So what sodium does is that sodium will give out this 1 electron. When sodium loses this 1 electron, this becomes the valence shell of sodium. So when sodium loses this 1 electron, its electronic configuration becomes 2, 8. This is the electronic configuration of neon. But as it is sodium, it cannot become neon by itself. It will remain sodium. So this sodium has 2 and 8 electrons in the first and second cell. Now, before we have done that, sodium has 11 protons, 11 electrons, because its atomic number is 11. So when sodium loses this 1 electron, its electronic configuration becomes 2, 8. Now the number of electrons for sodium is 2 plus 8 will be equal to 10 electrons. But sodium has 11 protons here. When sodium has this 10 electrons and 11 protons together, then sodium has 1 proton more than this electron. So sodium will become positively charged ion. Because of this, we call it as metal. Next, let's define non-metal. Those elements which can gain electrons and become negatively charged ions. Non-metals are those elements which can gain electron and become negatively charged ion. Gaining electron means, let's take an example, chlorine. Its atomic number is 17. So chlorine has 17 protons, 17 electrons. Let's write electronic configuration of chlorine. Electronic configuration of chlorine is 2, 8, 7. Now we apply octet rule here again. When we apply octet rule here, chlorine, if it wants to become stable, that is, if you want to attain the stable electronic configuration of nearest inert gas, then from this valence shell, chlorine has to either lose 7 electron, or if it take from outside to make it 8, then it need to take 1 electron from outside. Giving out 7 electron and taking 1 electron, giving out 7 electron is far more easier than taking 1 electron from outside. So for that, what chlorine will do is that chlorine will take 1 electron from outside and it will become, and will have electronic configuration 2, 8, 8. Now before, chlorine has 17 proton and 17 electron, but after taking 1 electron from outside, now total number of electrons for chlorine is 2 plus 8, 10 plus 8, 18 electrons. So because of this, now it has more electron as compared to proton. Then chlorine will become negatively charged ion. This type of elements are called nonmetals. Now, one important thing is that sodium, we write 1 positive here, and chlorine, we write 1 negative here. This 1 positive sign for sodium means that sodium has lost 1 electron, and 1 negative sign for chlorine means chlorine has gained 1 electron. Next, there are some more elements like calcium. You will see 2 plus. 2 plus means chlorine has given out 2 electrons. In some element like, say for example, oxygen, you will see 2 minus. This means oxygen has taken 2 electrons from outside. So next, now let's begin the lesson. When you see your periodic table properly, you will see that this part of the table, which is this part of the table, which up to this yellow color, these are all metal, and this side they are non-metals, and in the middle you will see this zigzag series of elements, they are metalloids. Non-metals, they are found in extreme left side of the periodic table. Metals, they are found in extreme left side of the periodic table. Non-metals, they are found in extreme right side of the periodic table. In between metals and non-metals, you will see one zigzag line formed by some of the elements. They are all metalloids. This includes boron, silicon, germanium, arsenic, antimoney, tellurium, and polonium. These elements are metalloids. Next, physical properties of metals and nonmetals. These physical properties of metals and nonmetals you have already done in lower classes also, so let's revise it slowly. First, metals are hard. Say for example, let's take an example, iron. Iron is a metal. Iron is here. Iron is a metal. Iron is hard. Most of the metals, they are hard. Property number 2 for metal. Metals are good conductor of heat and electricity. Metals, they are very good conductor of heat and electricity. Most of the metals, they conduct heat and electricity. Next, third, metals are malleable. By this word malleable, it means metals, by the word malleable, it means they can be beaten into very thin sheets. By the word malleable, it means that metals can be beaten into very thin sheet. And the fourth point is metals are ductile. By the word ductile, it means they can be drawn into very thin wires. So metals are ductile. It means we can make a very thin wire out of metal. Because of this, most of the wires which we use in our homes, they are either made of aluminium or copper. This is because aluminium, copper, they are metals and we can convert them into very thin wires. And the next one, metals are sonorous. By the word sonorous, it means metals produce ringing sound when they are stuck. That means when we hit a metal, it produces the sound of ringing. So this producing of ringing sound for metal, we call it as sonorous. And then last one, metals have high tensile strength. By this point, it means metals have high tensile strength, means metals can carry very heavy loads on them. That's why most of the vehicles which carry heavy loads, the body parts of those vehicles are made of metals. Because of this, we say metals have high tensile strength. Now let's discuss about properties of nonmetals. Next, properties of nonmetals. First, property number 1. Nonmetals are not hard. Nonmetals are not hard because most of the nonmetals, they do not exist in solid state. Most of the nonmetals, they exist in gaseous state. Because of that, we say nonmetals are not hard. Point number 2, nonmetals are bad conductor of heat and electricity. We say nonmetals are bad conductor of heat and electricity because nonmetals do not conduct electricity. A gas cannot conduct electricity. Because of that, we say nonmetals are bad conductor of heat and electricity. And the third one, nonmetals are not renewable. This means nonmetals cannot be beaten into very thin sheet. And number 4, nonmetals are not ductile. This means nonmetals, they cannot be drawn into very thin wires. And point number 5, nonmetals are non-sonorous. This means nonmetals, they do not produce ringing sound when we hit. If you wave your hand through air, then air will not produce any ringing sound. This is because air is a mixture of different gases and all those gases are nonmetals. And point number 6, nonmetals have very low tensile strength. This means non-metals cannot carry heavy things on them. Say for example, if I keep this duster above in air, it will not remain in air. If I leave it, it will fall down. This is because gases cannot carry anything in them. Because of that, non-metals, they have very low tensile strength. They can carry only those things whose weight is very low. Now next part we have is some exception on general trends. And the first one is some exception on general trends. The first one, point number one, is physical state. By physical state, it means how they appear. So when we see physical state on for some of the metals and non-metals, they do not follow the order. Say for example, we have said that metals are generally hard, and they are solid, but mercury is liquid at room temperature. This is an exception. Mercury is a metal, but it is liquid at room temperature, and this is an exception. Next, the next point is melting and boiling point. Oh, sorry, I forgot to mention this point. Metals have high melting and boiling point. And non-metals have low melting and boiling point. Please note down these 2 points in physical properties of metals and non-metals. Now next, melting and boiling point. We have written here that non-metals have low melting and boiling point, but there are some non-metals which have very high melting and boiling point, like for example diamond. Diamond and graphite, they have very high melting and boiling point in case of non-metals. And this diamond and graphite, they are made up of carbon. Diamond and graphite, they have very high melting and boiling point. And in some metals, we have written that metals have high melting and boiling point, but there are some metals which have very low melting and boiling point, like for example gallium. And we have one more metal, that is cesium. They have very sodium, potassium, gallium and cesium, they have very low melting point. Gallium, it can even melt if we keep it in our palm. So next, luster. Next one, metals have shining appearance on freshly cut surface. Metals have shining appearance on freshly cut surface, but non-metals do not have luster. We say metals are lusters, but non-metals, they do not have luster. So when we discuss about luster in metals and non-metals, you will find that there is a non-metal We have written here that non-metal do not have luster, but there is one non-metal which is solid, and it is iodine. So iodine have luster. Next, hardness. We have done that metals are generally hard and non-metals are not hard. But when we see hardness, there are some metals like sodium which can be cut with a knife, and we have diamond, which is the hardest substance known. So hardness, sodium can be easily cut with a knife. That means sodium is not hard. And diamond is a non-metal made of carbon, and it is the hardest substance known on Earth. Next, electrical conductivity. Let's write down the conductivity. We have done that metals are good conductor of electricity and non-metals are bad conductor of electricity. But there is a non-metal called graphite, and it is made up of carbon. Graphite, it is made up of carbon, and graphite is a good conductor. So all these things, they are exceptional cases. Even if some of the metals show one or two properties similar to non-metal, but remaining properties they have similar to metal, that's why they are placed along with metal. And there are some non-metal which have some properties which is similar to metals, but they are placed along with non-metal because in remaining properties they are similar to non-metals. And next, we have third group of element called metalloids. So let's rub off this part. We have third group of element called metalloids, and they have both properties of metals and non-metals. They have properties of both metals and non-metals. Let's take an example, silicon. Silicon, it is a metalloid, and it is bad conductor at room temperature, but when you increase temperature, it becomes good conductor. So you will study in detail about metalloids when you reach higher classes. That's all for physical properties of metals and non-metals and some exceptional cases. Now let's move on to chemical properties of metals and non-metals. So for chemical properties, we will study only some important points like formation of oxides, next, and reaction. We will in these physical properties of chemical properties of metals and non-metals, we will study only about some important properties like formation of oxides, what happens when that oxide react with an acid, what happens when that oxide react with a base. So first of all, let's discuss about chemical properties of metals and non-metals. property number 1. Formation of oxides. Formation of oxides means what happens when a metal reacts with oxygen and what happens when a non-metal reacts with oxygen. So first of all, let's discuss about formation of oxides for metal. Metals react with oxygen and there is formation of metal oxide. Okay, let's take an example. First, let's start with a simple one. Sodium plus oxygen. When we write this oxygen, you should write oxygen in molecular form every time because most of the gases they exist in molecular form. That's why we write O2. Sodium plus oxygen will give you an oxide. So let's find out the chemical formula of oxide formed by sodium dioxide. You cannot directly write one sodium react with 2 oxygen and you cannot directly write NaO2. This would not be correct. So first of all, we have to find out what type of chemical formula will be there. So for that, what we will do is that we will write down electronic configuration of sodium 2A1. For oxygen 2,6. After that, we will apply what we do in chemical bond. It has sodium has 1 electron in the valence shell, so valency of sodium is 1. Oxygen has 6 electron, means if it is more than 5, then we make it 8 minus. So here is 6, so 8 minus 6 is 2. So valency of oxygen is 2. Oxygen valency is 2. Let's close them. Then what we get is that we will get Na2O. We will write Na2O. This is sodium oxide. So next, remaining elements also react in the same way, and let's take the next one. Let's say magnesium plus oxygen will give you 2, 8, 2, 2, 6. Magnesium valency 2, same process. Oxygen valency 2. We will cut both of them. With 1 remains. We will bring this one here, then we will get MgO. That is magnesium oxide. So in this way, metals they react with oxygen to form metal oxide, and this metal oxide they have a nature, we call it as basic. Metal oxides are basic in nature. There are some metal oxide which can dissolve in water. There are some metal oxide which can dissolve in water, and those metal oxide they are called alkali. When you dissolve this metal oxide in water, you will get a base. So we say that metal oxides are basic in nature. Next, the next one is what will happen when metal oxide is mixed with acid and base. So let's take the first sodium oxide. Let's say we react it with hydrochloric acid. What will happen when sodium oxide react with hydrochloric acid? When sodium oxide react with hydrochloric acid, first of all, as we have done in our previous classes, first of all, let's break down their ions. So for breaking down ions, what we will do is that we will divide this sodium oxide into 2 parts. That is sodium positive part, oxygen negative part. I have already told you how to break down ions. Metal will become positive ion, non-metal will become negative ion. In hydrochloric acid, hydrogen will become positive ion, chlorine will become negative ion. This positive and this negative, they will attract each other. This negative and this positive, they will attract each other. Then there is the formation of H2O, and when these two attract, then there will be formation of NaCl. So this means metal oxide, when they react with acid, they form salt and water. So metal oxide, when they react with acid, they form salt and water. So we can write this as metal oxide plus acid gives salt and water. This is general formula for reaction of metal oxide with acid. Metal oxide plus acid gives salt and water. Now, what will happen when metal oxide react with base? Most of the metal oxides, they do not react with base, but there are some metal oxide like aluminum oxide. There are some metal oxide like aluminum oxide, and they readily react with base sodium hydroxide to form a new salt. So let's see aluminum oxide plus sodium hydroxide. Aluminum oxide is the only metal oxide which react with base sodium hydroxide, and when they react with each other, they form a salt called sodium meta-aluminate. So it becomes NaAl2. That is, this salt is sodium meta-aluminate, and we also call water. So aluminum oxide, it reacts with sodium hydroxide to form sodium meta-aluminate along with water. Next, reaction of nonmetals. Nonmetals, what happens when they react with oxygen? Let's take one nonmetal, let's say chlorine plus oxygen. Okay, let's take another one, sulfur. Sulfur plus oxygen will give you sulfur dioxide. We will apply the same formula, but when we apply the same formula, we will get sulfur dioxide. Sulfur plus oxygen gives you sulfur dioxide, or sometimes it gives sulfur oxide also. Let's say sulfur plus oxygen gives sulfur oxide. So nonmetal react with oxygen to form nonmetal oxide, and this nonmetal oxide, they are acidic in nature. Acidic in nature means when you mix this nonmetal oxide with water, then they will form acid. See, for example, let's say we take this sulfur oxide and we mix with water, and let's say there is formation of salt and hydrogen sulfide. This is an acid. So when nonmetal oxide react with oxygen, they form when nonmetal react with oxygen, they form nonmetal oxide, and nonmetal oxide are acidic in nature. When this means that when nonmetal oxide are mixed with water, they form acid. Now next, reaction with water. First, let's discuss about metals. metals plus water. What will happen when metal react with water? Most of the metal, they will not react with water. Say for example, let's take an example. If you keep a piece of iron inside water for 10 years, then iron will remain there. It will not react with water. But there are some metal which react with water. Let's say sodium. When you put sodium in water, then they produce some hissing sound. Hissing sound means there will be some sound like burning. And when this sodium react with water, they form sodium hydroxide. So sodium react with water producing hissing sound to form sodium hydroxide. There are, and this process gives off hydrogen and there is release of heat. So sodium react with water to form sodium hydroxide, hydrogen gas, and it produces large amount of heat. Next, reaction of the same thing will happen when you react potassium with water. You will get potassium hydroxide, and calcium also will undergo the same process. You can see that in your textbook. And the next one, reaction of metal along with water. So this one, some metals react with water, and this is very confusing, so see properly. There are three ways of reacting metal with water. But these metals, they will react with water only when these metals are hot. They will not react with water when they are cold. These metals, they will react with water only when they are hot. So it produces three important things. First, water can be in three states. First, water can be in three states. First, cold water, hot, steam. Water can be in three forms. It can be cold water, it can be hot water, it can be steam. Most of the metal they do not react with this cold water. If they have to react, they will react with hot water and steam here. Because we will discuss about cold water in other lessons. Here we will discuss only about hot water. So when metals react with hot water, then they form metal hydroxide. When metals react with hot water, they form metal hydroxide. When metals react with steam, they form metal oxide. Even if they react with cold water also, they form metal hydroxide. But the most important thing here is that when they react with hot water, steam or cold water, the metal should be hot, because they will not react when the metal will not react with all these three when they are cold. So metals also should be hot. So first of all, let's take an example. Magnesium and magnesium. So magnesium is solid. If we react with water, then it is hot to form magnesium. It react with hot water to form magnesium hydroxide, and there will be release of hydrogen. The same magnesium, it will react with water. It will be in the form of steam. When this magnesium react with water in the form of steam, then there will be formation of magnesium oxide and water. Magnesium oxide and hydrogen. Next, zinc, aluminium and iron, they react with steam. Zinc, aluminium and iron, all these three, they react with steam only to form their respective oxide. When zinc react with water in the form of steam, then there will be formation of zinc oxide. When aluminum react with steam, then there will be formation of aluminum oxide. And when iron react with steam, then there will be formation of iron oxide. Iron oxide will be in two forms. One will be FeO or Fe2O3. When valency of iron is 2, then it will form iron oxide. When valency of iron is 3, then it will form this. So, zinc, aluminum and iron, they react with steam to form zinc oxide, aluminum oxide and iron oxide. This is about reaction with water. Now reaction with dilute acid. Let's discuss about atoms first. Metals react with dilute acid to form salt and hydrogen gas. Let's take an example. Let's say sodium react with hydrochloric acid to form salt, that is sodium chloride, this is the salt, and hydrogen gas. Next, let's say calcium react with hydrochloric acid to form calcium chloride and hydrogen gas. So all metals, they react with dilute, most of the metals, let's say not all, let's say most of the metals, they react with dilute acid to form salt and hydrogen gas. And next, non-metals, they do not react with dilute acid. So with this we completed our class, and you have some questions in Let's Answer This. So those questions which are present in Let's Answer This page number 92, they are your homework up to question number 8, and all the answers for those questions, they are written. I have already written them in the board when I explained you. So when you watch this video at home, please make sure that you keep one notebook with you and note down all the important points. That's all.